In this lecture, I'm going to review probability distribution curves, and then we're going to try to find critical value T alpha over 2. So what's the probability distribution? Probability distribution is a description that gives the probability of each value or range of values of the random variable. Probability distribution for a random variable can be given to us in the form of a table, graph, or formula. Probability distribution curve describes the shape of the distribution, which depends on many factors. This is often called density curve. The total area under such curve is always equal to 1. Here are some common probability distributions: standard normal distribution, student t-distribution, chi-square distribution, and f-distribution. These probability distributions are used in different situations with the different criteria for different applications. What is significance level alpha? It's a numerical value. It is between 0 and 1 and is associated with the right tail of the probability distribution curve or density curve. The area of the right tail is alpha over 2. Now let's look at confidence level 1 minus alpha times 100%. Confidence level is a numerical value associated with the middle area under the probability distribution curve. The middle area is 1 minus alpha, and alpha over 2 is the area for each tail on either side. What's the critical value? It's a numerical value that separates the right tail of the probability distribution curve with area alpha over 2 from the rest of the curve. So the right tail has the area alpha over 2, and the area of the left side is 1 minus alpha over 2. The value that separates these two regions is called critical value. Now we're going to talk about student t-distribution. It's a normal probability distribution with mean of 0, but a known standard deviation. The total area under the density curve again is equal to 1. The density curve for a student t-distribution is symmetric and bell-shaped. This distribution is often referred to as t-distribution. The shape also depends on degrees of freedom for the collection of sample data. Now let's talk about degrees of freedom. In statistics, the number of degrees of freedom is the number of values in a final calculation of statistics that are free to vary, that are free to change. Here is an example of degrees of freedom. Suppose I have 7 different shirts, one for each day. Starting Monday, I have 7 shirts to choose from. But on Tuesday, I would have only 6 shirts to choose from. When Saturday comes, I have 2 choices of shirts. But on Sunday, there is no choice. I have 1 shirt left, and that's the shirt that I have to wear. So in this example, the degrees of freedom is 6. You can think of it as I had options in 6 days, but on the 7th day, there is only 1 shirt left, so there is no choice on that day. So now let's look at critical value T alpha over 2. We use T distribution. Critical value separates the right tail region with the area alpha over 2. We use T distribution table or technology to find such critical value, which also depends on corresponding degrees of freedom. How to find critical value? So we're going to draw the T distribution curve. We're going to shade and label the right tail region with the area alpha over 2. We're going to compute the left area, which is 1 minus alpha over 2. And then we're going to use student T distribution table or technology to find the critical value. In this example, we need to find critical value T alpha over 2 for alpha equal to 0.01 with the degrees of freedom 14. We're given alpha, but the right tail area is alpha over 2, which is 0.005. And the left area would be 1 minus that, which is 0.995. Also, we're given the degrees of freedom to be 14. Now we can use T distribution table or technology to find this critical value. In this class, we will be using TI calculator. So we're going to press second, vars, option 4 for inverse T. Now, if your calculator displays a menu, you simply enter the required items. The area is for the left area, and DF is for degrees of freedom. Now we're going to press paste, and then we're going to hit enter. Now, if your calculator does not display a menu, we simply enter the required items and then press enter. So we start with the left area, followed by degrees of freedom. Of course, you separate them with comma, and then you hit enter. So the critical value T of 0.005 with degrees of freedom 14 is 2.977. Now let's find critical value T for 90% confidence level with the degrees of freedom 10. So the confidence level is 90%. This means alpha, the significance level, must be 0.1. And the area of the right tail will be alpha over 2, which is 0.05, and the left area would be 0.95. Now, using the t-distribution table or technology, again, we're going to be using TI, second, vars, option 4 for inverse t. With the menu, we enter the left area and the degrees of freedom. We press paste, and then we hit enter. In case if your calculator does not have a menu, you simply enter the required items and then press enter. You of course separate the items by comma. So left area, comma, degrees of freedom. So the critical value T of 0.05 with the degrees of freedom 10 is 1.812. I hope this presentation helped you understand critical values and how to find T alpha over 2 critical value.